Hi. Hi, welcome to the ZP vlog and podcast for the week ending the 27th of March 2022. We've done this as a recording this week. We do also live stream it, but we think there's some problems with YouTube, so we've also made a live streaming of the vlog and podcast. So, first thing I want to talk about is at ZP, we do have our Purine Sensors. We bought the IP for these Purine Sensors a couple of years ago. These Purine Sensors are sort of based on a Russian purple formulation, and they were originally developed to really help with the understanding of tissue damage. I've sort of said that these sensors, they've got a few applications. Originally it was for the idea of stroke. I think because epilepsy also has purine as a biomarker, there's been some interest in using them in epilepsy. So we find them used in stroke, epilepsy. Then I think some people are interested in using purines in sports applications. I think that's really kind of interesting. In sports applications, the purine is a marker of kind of stress, let's say, of the tissue. And so people have done that. So what we've done now is put out a bit of a video so that people can essentially follow it along and set up these purine systems. So that's a little bit of news from Zimmer Peacock for this week. This is also some news that we put out for ZP this week, and I'll just sort of talk about it very quickly, which is if you use a stirrer plate in a lab. Even if you don't apply heat to that stirrer plate, you can feel those stirrer plates getting sometimes quite warm. And then there's a lot of friction going on, there's a lot of energy going into those stirrers, and some of that energy is actually converted into heat rather than just kinetic motion. And we ended up putting a sort of thermocouple into a beaker and measuring how much temperature rise we got. I think the probably beaker had about a volume of about 100 milliliters. The temperature actually went from room temperature, which the room temperature was around about 22 degrees C. We went up to about 33 degrees C. So it tells you that there's a significant amount of heat sometimes coming off some of these stirrers. So first of all, be careful. Don't just assume it's room temperature. Actually, it can be 33 degrees C. And if you want to prevent it, then I would actually we suggest you put a Petri dish, some sort of insulator between you and the hot plate. And so a Petri dish is quite good because it raises you just off the surface of the stirrer, and air is quite a good insulator actually, so it acts as a good insulator. So just be careful that if you're using stirrers and you're not thinking you're heating, you could actually be doing some significant heating. When we used the Petri dish, we got to a temperature of about 24 degrees C, but as I say, if we just did the same experiment without the Petri dish as the insulating layer, we got to about 33 degrees C. So just be careful. So we like to put out those sort of anecdotes on occasions. Now, we also did our Developer Zone webinar on Thursday. So every Thursday, 8 AM London time, we do a webinar specifically for members of our ZP Developer Zone. This week we talked about MIPS, molecular and printed polymers, and we also talked about how to use screen printed electrodes with organic solvents. And we got some nice feedback from the questioner on the organic solvent part, and we appreciate the feedback. We also attended a conference called LOPEC this week. So LOPEC is a conference held in Germany about printed electronics. Because of biosensors are also printed, I think people were quite interested in hearing about biosensors, so we were invited and we gave a talk on biosensors at LOPEC. I think this is just a sort of caution or a warning. Let's say that we do sell lactic acid sensors, and we made a video this week where we had to be really explicit about it and say, look, when testing these lactic acid sensors, make sure you use lactic acid, not lactate. So I think the problem comes down to lactic and lactate are chiral molecules. So you have a left-hand version of the molecule, a right-hand version of the molecule. if you try to put the right-hand version of the molecule on top of the left-hand version, they don't quite match up. Because they're like our hands. Our hands are chiral, and lactic and lactate are also chiral. So when people buy lactate, they're often getting a very purified version. They only get one chirality. They end up sometimes buying the wrong chirality. So they're testing this enzyme-based sensor with a molecule that's in the wrong chirality, and it doesn't work because the enzyme's so specific. Now, lactic acid is actually racemic, I think, and so you get left and right. But either way, actually, lactic acid does work very well, and lactate doesn't, which says a lot about the specificity of these sensors. So I just want to give people a warning about that. Make sure that you're using lactate. Make sure you probably follow on with the video, and then you should be in a lot better place for actually testing these sensors. Change of gear slightly here. Now we're talking about a conference that we're going to attend called Groundswell. Groundswell is really about sustainable agriculture, and this really kind of resonates with us at ZP. Our whole nitrate sensor, we've developed our nitrate sensor so really we can help the farmer in saving money. And by the way, when we started the nitrate sensor, the cost of fertilizer was around about $250 per ton. Today it's $1,000 per ton, and I really wonder, there's such a squeeze on energy these days in the world, whether this pricing is going to come down that much. So when we're going to go to Groundswell, and we're going to talk about our nitrate sensor there. Next, we've invested along with a investor $250,000 of US dollars in a new clean room, and the guys, because there's significant efforts going on here, significant investments. So the guys put together a opening ceremony, which is really quite sweet, and our CEO Evan opened up the clean room, and the guys celebrated the opening of the new Class 7 clean room. And then finally, this is related to that lactic acid let's say conversation we were having earlier on. If you're going to make a sweat sensor, and there's many people who want to make a sweat sensor for measuring lactic acid in sweat, you sometimes need a way of bringing the sweat, let's say, to the sensor. And so at ZP we have put a video out there on how to provide a conduit for the sweat to the sensor. So we hope essentially that was useful. So if I was to summarize this week, first of all, if you've watched one of our vlogs or podcast attempts this week, there was a big buffering issue, and so I've ended up recording this. That's just as an aside, but as a business, we've been very busy opening up new clean rooms, booking conferences to new soil conferences, attending conferences in Germany, putting out videos on how to set up the Purine systems, putting videos out on how to test lactic acid sensors, and putting videos out on how to construct microfluidics for doing sweat analysis. So I think it's quite a lot again from Zimmer and Peacock, and as per normal, we'll remain nice and busy again this week. If you have any questions from us, please don't hesitate to contact us. As I say, if you've been trying to follow this vlog and podcast live this week, we've been having some buffering issues. I've tried some live fixing, but in the end I've decided to record this. Okay, thanks very much, take care, and see some of you on Thursday for our ZP Developer Zone webinar. Okay, thanks very much.